Okay, let us now move ahead. Features of the abstract class. That is the first feature. First feature of the abstract class is a class is abstract if it has at least one pure virtual function. As I have already told you, when it becomes abstract class, it has a pure virtual function, at least one. It can have many pure virtual function, but at least one pure function exists, then that class is called as abstract class. Okay, and for that, when you are saying that the feature of abstract class, you want to represent this property with the help of one example. So we can show this with the help of example. So there is a class test. In this, we are having the variable int x, and then we are showing that the virtual void show is equal to 0. That means we are declaring here a pure virtual function. When you write a pure virtual function, we cannot write the body of that function in that class, so that this class becomes the abstract class. Next, we are writing the int get x function. Here we are returning x. That means you are writing the body of the function. So we have one function which is a virtual function and another function which is the simple function. So when we are writing a test t, that means for the class test and the object is t. So it gets a output as a compilation error. Now why this error happens? Because we cannot declare the object of a class which is called as abstract class. So if an abstract class is there, in the main function we cannot write a object of that particular class. We cannot write object of that particular class which is an abstract class. Okay, and what abstract class can be inherited in the derived class, then the derived class objects we can declare, right? So when we are writing this, instead of, if you write the virtual void, then test and scope resolution and show, then compiler error will here you don't have to declare this part. Okay, because you are just using the abstract class and you want to show that this feature. Okay, so we can have a pointers and references towards the abstract class type. Okay, so the property is we can have the pointers. Do you know pointers? What do you mean by pointers? And references of abstract class type, what does it mean? What is a pointer?
Then pointer used for location storage.
Yes. So let us talk about the pointers. Okay, so basically a pointer will access a memory location. Okay, so it is actually accessing that memory location, address of that memory location. Okay, so it is like another name or given to that particular memory location, which can find out the address of that particular location and stores it address. That means it points out that memory location. Okay, it points out that particular memory location. So it needs to store the address. It needs to store the address, right? When we are saying the pointer. Now, for example, in this, there is a class base, okay, having the our abstract method or function, sorry, a pure virtual method. That is given by the virtual keyword, then the data type, then the name of the function, which is equal to 0. Now you are saying that this is your pure virtual function which exists in the class base. Now this base class becomes what? It is called as
Abstract.
abstract class. Very good. Okay. Now next is you are deriving a class from this base class, right? From this base class. Then you are writing the body of this function void show cout in derived. Okay. What does this means? You are writing the body of the virtual function which exists in the abstract class base, and you are deriving this, or you are writing the definition inside the derived class. Okay, so when you are writing this definition, now you can make the object of your derived class, right? That is the one way, that you can declare the object of the derived class. Another way is you can declare the pointer of the base class, and it will now point it to the derived class method. It will point it to the derived class method. Now see here, pointers means what? It is now showing or pointing or the address. It is showing the address of the particular memory location. Okay, it just reflect out or points out to the memory location. Now memory location, it is saying that new derived. What you have written? Now just see here statement. What you have written? Base pointer BP is equal to new derived function. Now what does this means? It has created a object of the it has created a object. This is a new object of derived class, but it is a pointer of type base. That means this will now point towards the object of derived class, because new is an operator which will allocate the memory at the runtime. At the runtime, what is this new operator? New operator will allocate the memory, will allocate a memory at runtime or at execution time or at dynamic time. That means whenever the process of the final execution takes place, at that time it will allocate the memory. It will not allocate the memory at compile time. It will not allocate the memory at compile time. When it will allocate the memory? At runtime. And how? With the help of the pointer, base pointer, which will point out to this newly allocated memory. And when you are having a pointer, this pointer can access now the method show, which is the method of derived class, because you have created the memory allocation with the help of the derived class object. Okay, but it is called as a pointer. Okay, so pointer is nothing but this pointer will basically, when you reflect the pointer, you have to show star BP. Okay, now BP is just an object name given. Okay, this is a pointer which will access out the derived class. Now BP will, with the, because this is a pointer, so we cannot access with dot operator, right? This is a pointer, so we cannot have the dot operator. What we have instead of dot operator? Then arrow operator. What we have instead of dot operator? The pointer, arrow operator, and the name of the method. Now name of the method is show. Okay, so you are calling which one? Now the cursor jumps to which method? Show function, and it will find out what is written into show function. Cout int derived. Okay, so the cout means it will just output int derived, right? It will just output int derived, and because data type is int, it will return 0 and close. So when you run this program, what will be the output? The output is int derived. And from where this int derived comes? This comes from the derived class, because you have written the body of the show method in the derived class. So this pointer points to the derived class, though it is a pointer from the base class, but it is accessing at runtime, accessing the object at runtime, the memory location where this method is written. Okay, so it will jump out there and it will execute that, and then it will come towards the end when it now returns back here and print out whatever the things or variables, and then close this. Understood? Or any queries? Similarly, you can have the variable that already we discussed in the first unit, that new operator and delete operators can be used for declaring our data types also. When we are having a variable declaration using int instead of base, suppose it is int, right? अगर ये integer होता तो क्या होता? This is int star BP is equal to new int. Remember?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. So just here, what we are doing, we are making the pointer base pointer and accessing a memory location for the derived class. Okay. And because it is a pointer, we are not using dot operator. So we are using arrow operator to access the method. So now again we can have this one more example of the virtual function. See here, class A is there. Can you see class A? Virtual void display, cout base class invoked. Virtual void display cout base class is invoked. Okay, this we have written in the virtual void display. This is a virtual function. Okay, then we have a class B colon public A, then void display and derived class is invoked. Endl means it is taking a new line, cursor to the new
Breaking line.
line. Yes. Now int main we have a pointer a. See here, pointer a object. This is what pointer of base class, because you have written a. This is a base class, na, right? A and pointer this name. Then B object of derived class. यहाँ पे क्या है? This is B class name and this is a object of B. B is what? Derived class. B is what? Derived class.
Derived class.
Yes. Are you getting this? A is what? Base class.
Point.
B
Base
is
class.
so A is base class and we are declaring the pointer of base class. Then we are declaring a object. This is not pointer. This is object of B. B is derived class. Now, as this A is a pointer, it can hold the address, right? A is a pointer, no? A is a pointer because it is prefixed with star A, right? Now A is holding the address of B and B is what? It's an object, right? It's a object. So now what A is holding? A is holding the address of object that is B class object. It's just pointing to the memory location where the B object is there, right? Now this arrow operator you have to use, because when you are having a pointer you have to use arrow operator to call any method. Okay, so now A is pointer, arrow operator. See, this one is okay. This one is A, arrow operator, display. You are calling this method display.
Yes.
Okay, so display will now this display method will be called out and you are going to have here cursor will go to where this display method and it will have the cout statement derived class is invoked. Now next, this is called as late binding. Late binding means what? At compilation time there is no address allocation. At the runtime the address allocation is there and it is decided that this display function of the method display which is written inside the class, that is a derived class B, has to be executed, and this happens at the execution time, so that it is called as late binding. It is called as late binding. Okay, now this is one part. Now coming to the next part, now I want that the call has to be taken for the base class function. Now the call has to be taken for the base class function. So now I am using here, the pointer is there, right? This pointer is there, A comma OB. OB is nothing but it is the base class object. So ampersand OB, that means I am putting now in this pointer ampersand OB means the object of the A class. And now again I am here using A arrow display. Now the late binding occurs again at runtime. This will again makes a call to the display function which is here in the class A. So this will base class is invoked. Base class is invoked. Okay. So here A star display will now go to this function which is written in the class A. Now class A, because you have put the address of the class A object. Now this will pointer takes the decision that display function is which it has to execute. It has to execute class A display function at execution time. So again this is a late binding occurs. So when you run this program you will get the output as derived class is invoked because of this, and nextly you will get base class is invoked because of this statement. Okay. A compile time binding is also called as a early binding. Okay, and the late binding is a execution time binding. That means when we are not
Right.
decided, when we are using some dynamic memory, when we are using a dynamic memory using some pointers. Okay, so there is a concept of pointer where it will hold the address. Okay, it will hold the address. How it will hold address? By pointer. This is a pointer A. Okay, because it is written as star A, right? Star A, that means it pointer. But when you are assigning the address to pointer, A is equal to ampersand B. This ampersand B is nothing but it is the object of class B. Okay, so first time you are putting the address of class B object and telling the telling this, telling what, that you want this function of where the address is kept on the pointer. Pointer will point out to the display method of this particular object. Okay, you are telling let this. Okay, so this is called late binding. Similarly, you can change this afterwards. Once it is done, completed this task, what pointer holding this right now? It is holding object of B address. But in the next time, the same pointer, we are not using another pointer. We are not using another pointer. We are using the same pointer A. And now this time the address, because it is dynamically, now it will change the address of the object of A class and it will assign this A arrow display method. That means now dynamically it will change the address in the pointer variable A, and pointer variable A now goes to the display method and it will call out the display method. So it is called as late binding. Understood? That means we are not taking another pointer, but we are taking the same pointer and we are just changing the addresses at runtime. We have the next property. We do not override the pure virtual function in derived class. Then derived class also becomes the abstract class. What is that name? If we do not override the pure virtual function. What is pure virtual function? When we say that it is equal to 0 already in that abstract class. And if it is in derived class, okay, if you do not override pure virtual function in derived class, then derived class also becomes the abstract class, right? If you are not deriving, now the example is to clear this, you are having a class base virtual void show, in that is equal to, you are showing that this is a pure virtual function as you are writing is equal to 0. Similarly, you are writing a next class, class derived, which is a derived class and it inherits the property of public base class. But base class, when you are opening and closing, just you are nothing doing there, you are nothing writing the definition of the show method, then what it will understood? It will be understood by the compiler that we don't have the body of this virtual show function here also in derived class. So that means it is also again virtual. It is also again virtual. We have not decided here also. So it is again here virtual. So we are writing again, if object of the derived D, then it is again happening the compiler error, because the property says that we cannot declare the variable D. It is of the type abstract, because derived class, the following virtual function are pure within the derived. So we cannot declare the derived class object over here. If you write the definition, then you can write. But you are not writing definition of this show function, then it becomes again the derived class, also abstract class. Okay, that is one of the property. Then last is an abstract class can have the constructors. So we can have the constructor. Yes, for abstract class also we can have the constructor. For example, suppose class base is there, protected variable index is there in public, virtual void function which is equal to 0, that means this is a pure virtual function. And after that, for this class, abstract class, you are writing a constructor base in bracket int I, x is equal to I, that means you are calling here constructor and you are writing x is equal to I, that means you are assigning the I value to x. This is a constructor, parameterized constructor. Okay, so you can write the constructor for a class abstract which is in nature. So class derived public base, here you are writing the derived class which is inherited by the base class publicly, then its own variable int y, then the derived int I, int j. This is a constructor again, because I is coming from the base class and j is coming from the derived class. So you are actually calling here the base class colon base. Now what does it happening here? When you write like this way, one variable int I goes to the base I. Now in returns, it will call again the base constructor call in the base class, that is int I x is equal to I. So it will assign the value of I to the x variable, and now you are writing for the derived, then y is equal to j. So j value will be assigned to the y. So this is a derived class constructor. So in turn, you are writing a derived class as well as base class constructor. Then void function as the regular function. You are see out the display x value as well as y value. Now, when you write a main method, here you have to use the object of the derived class, and once you write their object of the derived class, this is a call to the constructor of the derived class. This is a call to the constructor of the derived class. Now what you are passing here, 4 comma 5, when you write this, you are passing a constructor call to the derived class. Now derived class, now cursor comes to here, derived class int I comma int j. Now it takes the value to I variable 4 and j variable 5. I variable 4 and the j variable 5. So I goes to the again constructor call to the base, and it assigns the x is equal to 4, and same way it assigns the in y is equal to j, that means 5 value to the y. Now this is a constructor call, and y is goes to the derived to the base class constructor. Now d dot function, this is a function call, as it is an object. D dot function call will be given call to this function, and it will display out the cout x is equal to value of x variable and y is equal to value of y variable. So the output will get as x is equal to, as you are passing 4, x is equal to 4, and then you are passing the 5, which in turn gets a value of j to y. So it is y is equal to 5. So output will be as x is equal to 4 and y is equal to 5. You will get this two values. Okay. So this is nothing but a call. We can call the abstract class as can have the constructors. So this is the example showing that the constructors. Now the benefits of inheritance, we can reuse the code from the base class. So the code reusability is possible with the help of inheritance. Similarly, using inheritance, we can increase features of class or methods by method overriding. Similarly, inheritance is used to use the existing features of the class. It is also used to achieve runtime polymorphism by using method overriding. And this we can organize the information in the hierarchical forms. Cost of inheritance. Inheritance decreases the execution speed due to the increased time and the efforts takes the program to jump through all the levels of overloaded classes. Inheritance makes two classes, base and inherited class, get tightly coupled. This means we cannot be used independently of each other. And as well as changes made in the parent class will affect the behavior of child class too. So overuse of inheritance makes the program more complex. So whenever we want to use the inheritance, then only you can use the inheritance. Okay. So, do you want? I need to continue.